My name is Leslie Sabina Villaseñor Cerón of the Universidad Autónoma del Estado de Hidalgo. I am going to present synthesis of nanohydroxyapatite using sodium citrate as a surfactant agent together the microwave assisted hydrothermal method. The hydroxyapatite is a ceramic materials of great interesting in the fields of the biomedicine due to its similarity to the inorganic phase present in the bones and the twins of mammals and vertebrates. In particular, natural bones is composed of approximately 69% by weight of the calcium phosphate is hydroxyapatite, the 20% by weight corresponding to the collagens, which forms a composite materials consists of collagen fibers and hydroxyapatite crystals. Additionally, about the 10% by weight is composed of water with a minimal amount consists of the organic materials such as proteins, polysaccharides, and fats. The fields of application of the hydroxyapatite depends directly of the size and morphology to the properties that give it. For the specific morphology and size surfactant have been implemented. An example is sodium citrate has properties such as biocompatibility, strong bonds, capacity with the calcium ions, and large dispersion capacity. Therefore, this study focus in the synthesis of nanohydroxyapatite using sodium citrate as surfactants at different concentrations, 0, 0.1, 0.5, 0 is the 1.0, 1.5, and 2.0% by weight. Through of the microwave assisted hydrothermal method, the synthesis being with the dissolution of the calcium and phosphate precursors in the deionized water under constant strain. Subsequently, the calcium precursor is added dropwise to the phosphate precursor, and the pH of the reaction is adjusted to the 10. The solution is transferred to the microwave and sieved at 200 degrees Celsius for 30 minutes. Finally, the results precipitate is recovered, washed with the ionized water, and dried at 19 degrees Celsius for 24 hours. The samples were characterized using a Fourier transformed infrared. In the figure 2, the spectrum corresponding to the hydroxyapatite samples and hydroxyapatite with sodium citrate at different concentration can be observed, showing the bands corresponding to the hydroxyl and phosphate groups. The characteristic of the hydroxyapatite. In the figure 3, we can observe the formation of the monoclinic and hexagonal phase. In the figure 4, shows an enlargement of the spectrum identified and displaying the coexistence of both fats and the monoclinic and hexagonal. And finally, high resolution transmission electron microscopic in the picture 5 This analysis confirms the presence on the both crystal fast and show a morphology of nanorods. The conclusion, the formation of both hexagonal and monoclinical crystal fast was established with their presence confirmed by high resolution transmission electron microscopy. The formation of the hydroxyapatite with a semi-spherical morphology was reported as the concentration of the sodium citrate increased. The morphology of the hydroxyapatite change of the predominantly nanorods. This indicates that the employed the surfactant stability, the morphology, and promotes the formation on the monoclinical phase. Thank you for your attention.